Okay, we're on centroid of a triangle. So let's define that. A centroid is the point of intersection of the medians of the triangle. So that's it. So let's use a diagram to show that. Okay, that's it. So you'll be wondering, what is a median? A median is a Savian that divides the sides of a triangle into two equal congruent parts. So again, you'll be wondering, what is a Savian? A Savian is a line segment from the vertex of a triangle to a side. So that's it. As you can see, AD, CF, AD, okay, let me write CF and BE, they are all Savian by the definition, because they run from the vertex to the side of the triangle. So they are all Savian. Yes, because they run from that, and since they divide the sides into two equal parts, they are now median. Is a Savian that is a median. We still have others like angle bisector. So that's it. So today we're going to want to get a relationship connecting the distance from the centroid to the vertex and the distance from that same centroid to the side, that's the base of the triangle. Do you get? We want to connect it from the vertex. They're in the ratio 1:2. So I want to prove that AG is to GD is 2:1, or maybe we want to prove that BG is to BE is to GE also 2:1, and CG is to GF also 2:1. So how do we start? We'll draw two parallel lines. Line parallel to BE from C. There's a line passing through C, but it's parallel to BE, and also a line parallel to FC and passes through B. And also we now reflect line AG about G, that I'm going to extend GD such that it will have the same length as AG. So let me introduce them. Okay, as you can see, let's call this H. So remember, I told you that AG will reflected line AG about G, so AG is equal to GH. And also I told you that this line is parallel to this, so we drew a line that is parallel to GE, and also a line parallel to FG. Okay. So what do you notice? We'll form a parallelogram. So I'm saying that G, or maybe let B, G, C, B, G, C, H is a parallelogram, as you can see, because it has two pairs of parallel. See, this is parallel to this, while this is parallel to this. So we'll have, okay, maybe let me add this so that you can see it. This is also the same line. So why this is this? And one of the properties of a parallelogram that the diagonals bisect each other. The diagonal bisects each other. So what are we trying to say here? We see that this line, so if we call this x, this is also x, and also if here is y, here is also y. So that's the one of the properties of a parallelogram. And since they are equal, do you see? So what do you have to say? Therefore, we've proved that the ratio of AG to GD is 2:1. That same logic for the other this. So if here is Z, here will be 2Z. So we've proved that. Okay, let's look at this question and see. AD is equal to 60 cm and G is equal to 30 cm. Then AG and BE respectively are that. So from the diagram, you see that G is the centroid of the triangle. The centroid is the point of intersection of the median. A median is a Savian that divides the side of a triangle into two equal parts. And a Savian is just a segment from the vertex to the side. So as you can see, these are all Savians because they run from the vertex to the side of a triangle. But if it divides the side into two equal parts, we call it a median. So, and the point of intersection of the median is called a centroid. So G is called a centroid, point of intersection of the three medians. So there is a property that the distance, so if I call AD M1, that AG from the vertex here is 2/3. I've proved it before. M1. This is 1/3 M1. So that same way, if we call this M2, so 2/3 M2, 1/3 M2, 1/3 M3, 2/3 M3. So that's it. So they're in the ratio of 1:2. So from there we can solve our equation. Therefore, we are looking for AG. AG is 2/3 M1. Our M1 is AD. That's the total length, which is 60. So I have 40. and they say G is 30. But from here we see that G is 1/3 2. Okay. And M2 is BE. 1/3 BE is 30. Do you get? GE, as you can see, is 1/3 M2. M2 is BE. So we notice that BE will now be 3 times 30, which is 90. So it's a very simple one, option B. So using the property of a centroid. So thank you.